Okay, this is problem number 13 on page 357. In this one, we're just going to use one variable to represent the length of an unstretched spring. So if this spring is just hanging from a ceiling or something like a slinky and it's just X long, what happens when I put weight on it, it has no weight on it, it just has an unstretched length. When I add weight to it, it stretches. And so I have its original length and it stretches by some extra amount. And then when I add more weight, I add 30 to it, it stretches, it goes from 15 to 18. So it still has this part, its unstretched length, but we've added more stretch to it. And what we're thinking in this is that there should be a relationship between the amount of weight you add and how much this stretch is to the amount of weight that you add and how much that new stretch is from its unstretched version. So if I let this part be X, then the new stretch here shown in red is 15 minus X. If I let that unstretched portion of the spring be its length when there's no weight at X, this new stretch right here will be 18 minus X that's shown in red. So instead of using variables for new stretch and weight, I'll just use words. I'm going to say the new stretch, the new length that it stretches, as a ratio to weight should be the same. Okay, so new stretch in this one was 15 minus X to 12 kilograms is, when I've got 30 kilograms, 18 minus X. And that's going to allow me to solve for X, I think, the unstretched version, just trying to work with one variable. So this is where obviously the stretch and the weight are proportional to each other. So cross multiplying 30 times 15 minus X is 12 times 18 minus X. So there are other ways to do this problem, just to set up a linear equation using finding a slope between 18 and 15 and 30 and 12, and then writing an equation and plugging in zero weight and finding out what X is that way too. But this way uses a proportion. So on here, if I'm going to add 30X to both sides, I'll have 18X, and subtracting 216 is 234. So X, the unstretched length of the spring, is 13. So 13 centimeters unstretched. That's when zero weight is on that spring. So if that's so, then if this is 13, then this new stretch here is 2. If this was 13, then the new stretch here is 13, 18 minus 13, or 5. So is 2 to 12 the same ratio as 5 to 30? So this is a 2 to 12, and this is 18 minus X is 5 to 30. And you can see that this is a 1 to 6 ratio, and this is a 1 to 6 ratio. So, and we can cross multiply those, and we get 60 equals 60. So anyway, that's one approach to number 13.